Shall I solve this question? So here, let us solve this question. So what is the control strategy? So basically, if you try to see, so you have a concentration, you are measuring the concentration. Basically, the concentration controller, you have the concentration controller which gives set point to TC1. You are measuring the temperature of CSTR. Concentration measurement, concentration controller, which gives set point to TC1. This in turn gives set point to, you have a cooling water jacket also. Cooling water in, cooling water out. So this gives set point to TC2. This gives set point to FC. So this one. So how many controllers you have? How many controllers you have? How many controllers you have? 4. So what are the controllers? Concentration controller, reactor temperature controller, TC1, TC2, cooling water temperature controller, and then FC. So these all 4 are in cascade. So basically, how, if you understand what is the functionality of this one. So let's say I want to maintain a concentration of, let's say, 0.5. So here feed comes in, this is my feed, and then feed out. So I want concentration of the reaction is, let's say, A gives B. Concentration of B is 0.5 here. Clear? So if I want to maintain concentration of 0.5, then reactor temperature should be, let's say, 400. So this concentration controller will give set point to this temperature controller. Clear? Now this temperature controller will give set point to this CSTR. So CSTR out, cooling water temperature outlet is 45 degrees. Now this cooling water temperature outlet will give set point to, let's say, 10 tons per hour of cooling water flow. So here everything is linked. So the if you see the linkage, concentration of the reactor depends upon the temperature of the reactor. Temperature of the reactor depends upon the cooling water temperature of outlet. Cooling water temperature outlet depends upon the flow of cooling water. So this is the 4 sequence. This is a good example. Just follow the example. Yes, Paul. Any questions that you have here? Now, which one is the fastest controller here? What are the four controllers is? Concentration control. See here, if you see four loops, concentration controller, TC1, TC2, FC. Which one will be fastest controller? FC. The innermost should always be fastest. What is the control strategy? Because you are taking multiple feedbacks. You are taking multiple measurements plus single manipulated variable. Multiple measurements plus single manipulated variable, which is nothing but a cascade control. FC flow controller, cooling water flow control. So what is the control strategies? Multiple measurements. How many measurements you have here? So you are measuring the concentration, you are measuring the temperature, you are measuring the temperature, you are measuring the flow. So basically you have four measurements. But finally, the concentration is controlled by just cooling water. If you understand the system, concentration of the reactor is controlled by just this cooling water. Cascade control. See, there is only one manipulated variable. That cooling water flow rate is something which you are manipulating. You are not changing anything. No. Suppose if my concentration is, suppose my objective is to maintain 0.5. If the concentration is 0.6, what do you change? You change ultimately the cooling water flow rate, because so the concentration control will give set point to temperature. This will give set point to this temperature control. This will give set point to this flow water. So ultimately, the concentration is a function of cooling water flow rates. You can ask one question: why do we should have these many controllers in series? We can directly change the cooling water flow rate, concentration control, because stepwise control is always effective and you know the system better, because the concentration doesn't depend upon the cooling water flow rate directly. It is indirectly depends, because concentration primarily depends upon temperature of the CSTR. Temperature of the CSTR depends upon temperature of the outlet cooling water flow rate. Temperature of the outlet cooling water flow rate depends upon the cooling water flow rate. And what is the questions that you see here? What is the control? First question: what is the control strategy? Cascade control. What is the primary control variable? What is the primary control variable? So what are the questions is, what is the primary control variable? how many values you are controlling? Concentration you are controlling, temperature of CSTR you are controlling, temperature of cooling water you are controlling. So concentration is your primary control variable. Because the primary control variable is concentration. No, here, see, first primary is you are controlling the concentration. How you are controlling the concentration? By controlling the temperature of CH. First understand the system, then only we'll appreciate the questions. How the system is working? The concentration is controlled by controlling the temperature of CSTR. So maybe we can write these points. See how the system works is the concentration is depends on temperature of CSTR. Temperature of CSTR depends on temperature of cooling water outlet. Temperature of cooling water outlet depends on flow of cooling water. So what is the primary control variable is concentration of the CSTR. So does everybody understood this question? Because this is one of the good examples of a cascade control. You are controlling in a cascade systems. See, the concentration of the CSTR depends upon the temperature of the CSTR. Temperature of the CSTR depends upon temperature of cooling water flow rate. Temperature of the cooling water flow rate depends upon the flow of cooling water flow rate. That is how the system is. So I think this is what is cascade control. We'll go to feed forward control. So what is feed forward control? Suppose if you are controlling level in a, what is the slowest controller out of in the previous question? LSP. This is it feed forward or feedback control? Is it feed forward or feedback? Which one is the slowest control in the previous question is concentration. Suppose if I want to change this to a feed forward control, then how do you change? This is actually feedback control, because your objective is to maintain the level and you are measuring the level. When it changes, you are opening the control valve, and it closes, you are closing the control valve. Suppose, what is the feed forward control for this one? You know where is the disturbance occurs. LSP. This is what is feed forward control. So why you are measuring the disturbance, and taking control action. Measuring the disturbance and taking control action is what is feed forward control. See, follow one example. Suppose if you are working as a controller, controlling level in a glass vessel is a feedback control. Well, remember one thing. So here once again, controlling the level in a glass vessel. Glass vessel, you can see the level. Suppose I have a mark. I have marked on a glass vessel. So your objective is to maintain up to that mark. Suppose if the level goes below the mark, then you will just close the outlet valve. Suppose if the level goes above the mark, then you will open the outlet valve. So that is feedback control. Feed forward control is controlling the level in an iron vessel. Iron or steel or any metal vessel is what is feed forward control. But you can't see the level, but you have to maintain at a particular value. But you can monitor the disturbance. So your inlet flow rate, there is a measurement. So if your inlet flow rate is measuring, and then you accordingly you are opening the control valve. That is what is feed forward control. Now, how do you take why we went from feedback to feed forward? Why do you went from feedback to feed forward? Is feed forward, what happens is feedback, what happens is the disturbance affects like this. Feedback. That means the level changes and you are bringing back. So feed forward is something like this. There is no effect of disturbance. Feed forward. Basically, ideal feed forward. So ideal feed forward is something like this, because why you went from feedback to feed forward is because your variable is changing or your variable is affecting. So I don't want my variable to get affected. So that is why you are going to feed forward. Now, suppose if you are given a task of maintaining the level in an iron vessel, so you are monitoring, let's say, inlet flow rate. Inlet flow rate suddenly goes from, let's say, 5 to 6 meter cube per hour. Then you have to go and open the valve now. But just hear me carefully. So how do you open the valve now? Let's say a simple example. So let's say here, if you go to feed forward, this is 5, this is also 5. Suddenly this has become 6. Now you have to increase the valve also to 6. So here the timing has to be extremely perfect. Suppose disturbance you have seen. Disturbance has become 5 to 6. Now when you are opening the valve, suppose if you open rapidly, then what happens is the level may come down. Suppose if you open the valve little late, the level may increase. But how do you control? How do you control? The question is how to control the level by looking at disturbance. How does this feed forward control works? How do you control the level? By looking at the disturbance. So what does this controller does is, suppose if there is a 1 by s, then you should have a transfer function of the system. So you have to feed the transfer function. This is not required for the feedback control. Feedback controller doesn't require any model. So you have this transfer function r by ars plus 1, ars plus 1. Now q naught of s equal to 1 by s. Then h of s is equal to, let's take r equal to 10, a equal to 0.25. So this is 10 by 2.5 s plus 1 into 1 by s. So this is 10 into 1 minus e power minus 3 by 2.5. Okay. Now you plot, let's say, capital H, how the height accumulates with respect to time. So height slowly accumulates and then it is going to reach a new steady state of 10 here. Suppose if you don't act here, then what happens is height slowly accumulates and reaches a new steady state of 10. Then after this dynamics, after dynamics, the valve will be opened in sequence. Now, if you say, let's take 1 minute time. 1 minute time, the accumulation of water is, let's say, 2 meters. Now, to take out this, let's say the starting value of the valve opening is 30%. 30%. Now, the starting value of the level is 30%. 30%. So now slowly the valve opening will also is calculated exactly proportional to this one, so that the level will never feel the effect of disturbance. This may be, let's say, 50%. So how water is going to be accumulated is studied using the transfer function, and accordingly the valve will be calculated, and the controller opens the cooling water flow rate like this, and the controller opens the cooling water flow rate. So that means when the controller measures that the cooling water flow rate changes from 5 to 6 immediately, then that disturbance will go to the LC. LC has to be fed with the model of the system. Using that model, it predicts the dynamics of the system. Based on the dynamics, it estimates how to act or how to open the cooling water flow rate. Has everybody understood how the feed-forward controller works? See, so when the Q naught is 1 by S, when Q naught of S is 1 by S, you have the transfer function R by ARS plus 1. Q naught of S equal to 1 by S. Then you put Q naught of S here. Then you will get H of S. Then you do the dynamics of H as a function of time. Once you see this dynamics, this is how high it is going to accumulate because of this dynamics. To eliminate this effect, this is how you have to open the valve. This is called as rejecting the disturbance. This is called as rejecting the disturbance. This is called as rejection of disturbance. See, if you try to see, the disturbance is going to affect my height. So that means if you try to see here, let's say height level is here, level is 2 meters. So the disturbance is going to increase my level like this. The disturbance is going to increase my level. This is disturbance. Disturbance. Now your control action should be the control action exactly in sequence, so that my level will never feel the effect of disturbance. Actual level. Actual level. This is how my disturbance is going to affect my level. This is how my control action is going to affect my level. This has to be perfectly in sequence so that my level will never feel the effect of disturbance. Suppose if you take the control action little early, also problem, because your level will decrease. If you control action little late, also problem. Your level will affect. My objective of feed forward control is the level should not affect. Is the objective of feed forward control. Is everybody with me? So just take time 2-3 minutes and understand. This is the slightly tough part in the entire PDC. So percentage is just some rough percentage I have taken. So the next point is how to draw the control loop for this one. So I'll discuss that tomorrow because I have so small work now. So I think I have introduced the feed forward control. I think with that one, maybe I'll take your doubts, but the control loop I will start tomorrow. So with that tomorrow, my chapter 5 is also completed. Then I need one class for the measurements and 1 or 2 classes for the problems. After measurements, I will take 1 or 2 classes for the problems again. So I think mostly 95% of the syllabus is completed. Only measurements I have some PPT. I'll just go through that PPT. So I'll close the class here. I am open for doubts. Yeah, measurements means instruments. But this December has come, so almost November ending is come. So I request you to, let's say, be active in, let's say, revising, since syllabus is almost done. So I request you to go through the entire PDC again. And if you have any doubts, let's clarify the doubts on PDC or let's say CRE or MEV, any doubts. So remember, this December is extremely crucial for you, because you have to make a lot of revisions here. Now, by now, you should stop reading the fresh topics and then you should be starting the revisions. Revisions is more important. So don't neglect the revisions, because revisions play a lot of role. How to revise the subject is class notes. So remember one thing, I always tell one points is all the previous problems should be solved at least twice, and you have to revise the notes, let's say 3-4 times. This is the minimum. Aptitude and maths, nothing to worry. If you solve all the previous problems, that is more than enough. You don't need any practice, because you have a lot of questions, because this is the one topic which is covering all the branches. You have so many examples. Test series is not required. Don't write any test series now, but test series is sometimes is a, let's say, confidence killer. Reason, because if you don't get any marks in the test series, then you will get dull. Test series is just to practice how to don't make test series as a gate exam. So whatever the marks that you get in test series doesn't have any relation to gate exam. Test series is just to get the practice. See, control outlet is the primary control variable, because that is what is your objective, no? What is the primary control variable? Your objective is to control the concentration, not the cooling water flow rate. Cooling water flow rate is you are manipulating. Because why it is primary, your objective, suppose if somebody asks, why did you put the control system here? My objective of the control system is to control the concentration at the outlet of the reactor. Is it or not? So that becomes your primary control value.